Okay, let us discuss this question. This is related to the effect of H plus on solubility. So we said our solubility can be increased or decreased if we add some complex ion that arrests the positive ion or negative ion, that increases the solubility. If I put some common ion so that reaction goes in the backward direction, that is decreases the solubility. So we have said complex ion formation can basically change the solubility. So one way to change the solubility is complex ion formation. This we have seen. Another way to change the solubility is to add some common ion. And you can also change the solubility basically by changing the pH. Change in pH can also be used to change the solubility. So change in pH is another way to change the solubility. This question is related to change in pH, that is effect of H+. What we are doing is we have AgNO3, concentration is 0.02 m, and let us say equal volume, so let us say V volume of this. I am mixing with HCN, and this has also concentration 0.02 m, and the volume is V. So what we are doing is we have AgNO3 VML and HCN VML. We are mixing these two things. So what we are doing, we can say something like this. So we have one beaker that contains V volume of AgNO3, concentration is 0.02 m, and another beaker we have that contains 0.02 m, and this time this is a V volume, again HCN. Now we are mixing these two. So what will happen? So first thing, after the mixing, AgNO3 will react with HCN. So you can keep copying. So AgNO3 reacts with HCN, and it will form AgCN plus H plus NO3 minus. You see, AgCN is basically a solid, so this reaction will go completion. So what is the mole of AgNO3 you have? You have 0.02 into V, so this is the mole of AgNO3, 0.02 into V. Mole of HCN is also 0.02 into V. So mole of HCN is 0.02 into V. So initially you have AgNO3 and HCN. After some time, so 1 mole reacts with 1 mole, so this total will react with this total. So after some time you will have 0 mole of this, 0 mole of this, AgCN that is formed 0.02 into V mole, H plus that is formed 0.02 into V mole, NO3 minus that is formed, that is 0.02 into V mole. I am interested only in H plus. So mole of H plus will be, I can say this is 0.02 into V. What is the total volume of solution? Total volume. This will be B plus B, because the volume of this is B, this is B. So total volume is 2B. So now I can plot what is the concentration of H plus. So concentration of H plus will be 0.02 into B divided by 2B. So this is 0.01 m. And this is fairly easy. Everybody knows if equal volume of two substances are mixed, concentration becomes half. So concentration of H plus will be 0.01 m. Now let us try to understand what the reaction will happen. Now you have in solution, you will have AgCN, H plus and NO3 minus. AgCN is a solid. So what will happen? So it will start dissolving. So in solution the reaction will have AgCN that is solid. So it will start dissolving. And mainly this reaction will go this side. So I have to put arrow. This arrow should be bigger. Now this will form Ag plus Cn minus. Are you getting? But Cn minus, as so equilibrium constant for this reaction is given to you, Ksp. Now as soon as this Cn minus will come into the solution, now this Cn minus will have another possibility. It can start reacting with H plus, because solution contains H plus. So it will react with H plus and it can form HCN. And equilibrium constant for this reaction is reverse of acidity constant. If you see from this side to this side, equilibrium constant is K, but from this side to this side, equilibrium constant is 1 by k. Now you have to set the reaction table. So let us say from here Ag plus comes x, Cn minus also comes x. Now this Cn minus through this reaction reacts by, and initial H plus you have, that is 0.01 m. So this will also react by bimole. So here we will have bimole HCN. Now Cn minus either you write here or you write here, you will have same. So this is also x minus bi. Now we can set two equations. First equation is x into x minus bi is equals to ksp. X into x minus pi, this is equals to ksp. So this is my equation number 1. Are you getting? Now I can set the second equation. So let me set the second equation. And second equation I can set from this equation. So this is bi divided by, so you can see this is bi divided by x minus bi into 0.01 minus bi. This should be equals to 1 by k. So this is my equation number 2. Are you getting? So we have two equations, two unknown, x and y are unknown. We have to solve. Basically equation 2 can be further modified. So equation 2, if I assume that bi is very small. So if y is very small, I can write 0.01 minus bi is approximately equals to 0.01. Keep copying fast. So I can follow the equation 2 can also be written as bi divided by x minus bi into 0.01. This is equals to 1 by k. Now this is equation 2 in a modified way. So let us say multiply equation 1 by 2. So what we will have if I multiply equation 1 by 2? So I will have x minus bi goes out. So we will have x bi divided by 0.01. This is equals to ksp by k. And the value of ksp is given to you. That is 2.2 into 10 to the power minus 16. And value of k is also given to you. That is 6.2 into 10 to the power minus 10. And if I solve this one, this comes out to be x bi is equals to, so after solving, this comes out to be x bi is equals to 0.03548 into 10 to the power minus 8. If you want, you can solve yourself. So let me wait for some time so that you can copy. So I want the value of x. So what we will use? Use equation 1. So equation 1 you have x into x minus bi is equals to ksp. So this is my equation 1. And the value of ksp is nothing but 2.2 into 10 to the power minus 16. So let us say I will have x square minus x bi is equals to 2.2 into 10 to the power minus 16. And the value of xy we have 0.3548 into 10 to the power minus 8. This is equals to 2.2 into 10 to the power minus 16. So here we will have x square is equals to, so 0.3548 into 10 to the power minus 8 plus 2.2 into 10 to the power minus 16. Now you see, this is 10 to the power minus 16, this is 10 to the power minus 8. So I can neglect this term because this is approximately equals to 0 with respect to this term. So x square is simply 0.03548 into 10 to the power minus 8. If I solve for x, so x come out to be, so this is x square. X comes out to be, if you take the root, this is comes out to be 5.95 into 10 to the power minus 5. You can solve yourself. So this is the solubility, because you see what is x? X is the concentration of Ag plus. So this is the concentration of Ag plus. And the concentration of Ag plus is basically total solubility. So solubility in this case you will have 5.95 into 10 to the power minus 5 m. If you want, we can check one assumption. In the problem we have done one assumption. And what is assumption is? So my assumption is basically you will have 0.01 minus bi, that we have written approximately equals to 0.01. So if I want, I can check this assumption. So now I know the value of x, I can find the value of x. by, because x into by is equals to 0.3548 into 10 to the power minus 8. If you plug the value of by, you can find the value of x. So if you plug the value of x, if you plug the value of x here, this equation, so you will find y comes out to be 5.96 into 10 to the power minus 5. So y comes out to be 5.96 into 10 to the power minus 5. So if you plug the value of x, you check yourself. So now see whether what is the error we are doing. So if I am writing 0.01 minus by it is 0.01, I am doing an error of y. So what is my error? Error is of y. What is my percentage error? So if I write percentage error, I have to write by divided by 0.01 minus by into 100. But 0.01 minus by is approximately equals to 0.01, so I write by 0.01 into 100. So this value will come, y is 5.96 10 to the power minus 5, 10 to the power minus 5 into 10 to the power 2 into 10 to the power 2, so 10 to the power minus 1. So this comes out to be 0.596%. So only 0.6% error I am doing. And that's why my assumption is valid. So basically we can check the assumption, not always. In some cases you can check the assumption, but even if you have taken assumption this one, you can see the assumption is valid because the equilibrium constant is very small. So this problem basically illustrates the concept of H plus, how H plus can change the solubility. You see, basically in the presence of H plus, solubility of this substance has increased. How this is so? You can see here. If you have written this one, then I can show you that. Let us wait for some time. So you see, what we will have in this case, Ag is Cn, Ag plus Cn minus. Now Cn minus can react with H plus. So what is happening? Cn minus is basically dragged by this equation. So Cn minus that is formed in the first step can be used in the second step. So this reaction will come this side because I am removing Cn minus. So Chatelain principle says, if I am removing Cn minus, to accomplish the removed Cn minus, AgCN will further dissociate. So solubility will increase. So if increase the concentration of H plus, solubility will increase. So in this case you can see, if the pH is decreased, solubility will increase. So I illustrate the same thing. If I decrease the pH, that is solution is acidic, then solubility will increase. So if I decrease the pH, solubility in this case will increase. That is very important point. In some cases you will see, if you increase the pH, solubility will decrease. Another way around, that is basically reverse to each other. In this case, if you are decreasing the pH, solubility increasing. In other cases you can also have, if you decrease the pH, solubility will also decrease. Because in some cases you will have, there is a substance that is coming out here that can react with OH minus. Now let us say this cation part can react with OH minus. So this can go this side. So if I increase the OH minus, concentration of this will increase, so solubility will increase. So in some cases OH minus can play important role also. So we'll discuss the next problem. I think you have copied this one. Pretty easy problem. This is a good problem.